Up to 80,000 ticks have been found on a single moose.
It involves the moose population in Minnesota, which in some parts of the state has been cut in half in the last 5 years.
In one brutal Maine winter, biologists documented something shocking. Moose calves dying at a rate of 90%. 9 out of 10 gone.
Winter ticks and their tragic effect on moose calves in northwestern Maine.
And the cause wasn't a fight or a predator chase.
This year, knock on wood, is that if we lost 87% of the calves last year.
These calves were being eaten alive from the outside in. This wasn't a tragedy, it was a real-time biological collapse driven by an ancient enemy that suddenly gained a deadly new edge. What's killing Maine's moose? Maine's forests have lost wolves, caribou, and panthers over the past 2 centuries, mostly because of unregulated hunting. But even with strict rules today, Maine faces a new wildlife crisis, and one of the strongest warnings came from the state's moose. At first, the signs appeared normal. A dead calf was found in one area, another was discovered miles away. Harsh winters often kill young moose, so early cases did not raise concern. But when biologists snowshoed into northern Maine and started finding several calves dead within the same patches of woods, the pattern shifted. These were not isolated winter losses. This was something hitting fast and repeating across the region. The calves' condition told the real story. Many were extremely thin. Large areas of fur were missing. Their skin was rubbed raw from constant scratching. Their rib bones showed sharply under their hides. The scenes pointed toward a widespread collapse, not routine seasonal mortality. The answer was crawling across their bodies. Thousands of tiny dark parasites, winter ticks, covered their legs, necks, and bellies. These ticks behave differently from the ones most people know. Instead of feeding briefly and dropping off, winter ticks cling to a single moose for months. They feed continuously as they grow. A single calf can carry tens of thousands of them at one time. As the ticks feed, the moose loses blood, body heat, and energy. Calves scratch and rub against trees, tearing out their remaining fur and exposing their skin to the cold. Many burn more calories trying to stay warm than they can replace through food, leading to a rapid decline. In earlier decades, early deep snow helped control tick numbers by knocking many onto the ground before they could attach to moose. That natural protection is now disappearing. Maine's autumns have become warmer, and winters have shortened. Snow arrives later and melts sooner, giving winter ticks a longer window to attach, feed, and survive. This shift has allowed winter tick populations to grow sharply, leaving young moose unable to withstand the heavy infestations. The result is one of the clearest and fastest wildlife warnings Maine has seen in years. Winter ticks are destroying Maine's moose. Across Maine's northern wildlife management districts, moose calves have been dying at rates that biologists describe as unprecedented. The cause is direct and brutal. Winter ticks are overwhelming these animals in numbers that were never seen before. Warmer winters have allowed tick larvae to survive in huge quantities, and this shift has changed the entire balance of the ecosystem. Researchers examining calves found shocking levels of infestation. Some calves carried more than 70,000 ticks at one time. That amount of blood loss is not survivable for an animal already entering winter with low energy reserves. Calves weaken fast. They stop feeding, lose body heat, and eventually collapse. When biologists find them in early spring, the damage is irreversible. The calves have already died from anemia, exposure, and starvation combined. Adult moose are not exempt from this crisis. They can tolerate blood loss for longer than calves, but constant irritation forces them into non-stop grooming. They rub against trees, bite at their skin, and scrape off their own fur. This leaves large patches of exposed pale skin, creating what experts call ghost moose. Without a full coat, these adults cannot handle freezing nights. Their bodies burn through energy rapidly, and they become weaker with each passing week. By late winter, many are barely functioning. But the tick problem is only one piece of a larger system failure. Moose populations in parts of Maine have been high for years. On the surface, this seems positive. Regenerating forests provide abundant food, and conditions look ideal for moose. But dense populations mean ticks move easily from one moose to another. When huge numbers of ticks survive one season, the infestation compounds the following year. What begins as a regional problem quickly becomes a statewide threat. Climate patterns are driving this cycle even further. Shorter winters delay snowfall, giving ticks more time in the fall to climb vegetation and attach to passing moose. Early spring thaws allow ticks to reproduce sooner. Every mild season boosts the next outbreak. As one biologist explained plainly, the ticks are simply responding to environmental changes. The moose, however, are built for deep snow, harsh cold, and predictable seasonal cycles, conditions that are disappearing. All these factors collide to create extreme mortality rates among calves in specific regions. The pattern is clear, direct, and deeply concerning. As winters warm and tick survival rises, Maine's moose are losing the fight. The situation is no longer a seasonal challenge. The deadly chain reaction killing Maine's moose. In several study zones tracked by Maine biologists, more than 80% of collared moose calves died before their first spring. In the hardest-hit areas, nearly 90% did not survive. Winter ticks remain the leading cause, thriving as shorter, warmer winters allow far more parasites to persist. Tens of thousands of ticks attach to a single calf, causing fatal blood loss, extreme stress, and severe anemia. What alarms wildlife teams most is the timing of these deaths. Calves push through deep snow and freezing temperatures only to collapse in late winter or early spring, precisely when their chances of survival should be rising. Field crews now describe the conditions as a tick storm, with every examined moose, alive or dead, covered in dense clusters of parasites that cling even after the animal has died. The landscape shows clear signs of suffering. Stripped tree bark from constant rubbing, bloodstains scattered across the snow, and trails littered with clumps of fur as calves try to ease the irritation. Some wildlife managers point to human-driven changes in forest structure as an added pressure. Large, uniform cuts create ideal feeding sites that draw moose into concentrated groups, which then become perfect breeding grounds for ticks. Under these conditions, even a strong population can accelerate its own decline. The collapse appears sudden, but it is the result of slow, steady ecological shifts, shorter winters, altered habitats, dense moose clusters, and overwhelming parasite loads. By the time spring arrives, the full cost of the season becomes painfully clear, revealing how strained the entire system has become. The shocking collapse. Moose are built for survival. They can sprint at 35 miles per hour, tolerate harsh winters with their thick fur, and defend themselves against wolves using speed and positioning. A newborn calf weighs around 35 pounds, stands within its first day, and gains steady strength through rapid nursing. But none of these abilities prepared them for the threat that would spread through Maine's forests: winter ticks. When biologists began reviewing field reports, a clear pattern emerged. Moose deaths were no longer isolated or seasonal. They formed clusters across the northern region, signaling a problem that traditional monitoring systems had failed to catch. The state quickly realized its older methods, limited research cycles, hunting permits, and basic habitat checks were not enough to understand what was happening in real time. To close this information gap, Maine launched one of the greatest moose tracking efforts in its history. Crews fitted calves and adult cows with GPS collars programmed to send location updates every few hours. If a collar stopped moving, response teams reached the site immediately. This allowed biologists to document exact death times, examine remains quickly, and identify the causes with far greater accuracy. For the first time, the state had continuous data instead of fragmented observations. The scale of the problem became impossible to deny. With the data in hand, the next challenge was to control the environmental conditions fueling the crisis. One of the most debated decisions was increasing moose hunting permits. The goal was not to boost hunting, but to reduce the number of available hosts for winter ticks. Fewer moose meant fewer parasites surviving into the next season, giving the herd a chance to stabilize over time. The state also moved toward stronger coordination with landowners and logging companies. Northern Maine's forests are shaped by large-scale timber harvests, which create vast young regrowth zones. These areas attract moose in high numbers, causing them to cluster closely together and making tick transmission far more efficient. By adjusting harvest rotations and diversifying regrowth patterns, Maine aimed to break up these concentration zones without damaging the timber industry. The response became a balance between ecology and economy, reducing moose density in some areas, reshaping forest structures, and using data to guide every decision. Maine's new approach marked a shift from passive monitoring to active year-round management designed to give the moose population a realistic chance to recover. Maine's adaptive plan. Maine responded to the growing moose crisis with a series of focused and practical actions aimed at protecting one of its most iconic animals. The state began by strengthening public education campaigns directed at hunters, outdoor workers, and people living in rural areas. The goal was simple: make sure everyone understood what winter tick damage looked like and why early reporting mattered. Since winter tick outbreaks often stay hidden until the situation becomes severe, the state urged people to report hairless moose, weak calves, or any unusual behavior immediately. These reports helped biologists track outbreaks in real time and identify which areas might be hit the hardest in the coming season. At the same time, Maine increased its investment in climate and environmental research. Scientists repeatedly emphasized one central point: shorter winters and warmer autumns create the perfect conditions for winter ticks to thrive. The state could manage moose populations and habitat quality, but it could not ignore the broader climate forces shaping the problem. This pushed Maine to connect wildlife management with long-term sustainability, even though moose management had never been considered part of climate policy before. The link was now unavoidable. Moose were becoming a clear example of how subtle warming trends could weaken a species built to survive some of the toughest environments in North America. To respond more effectively, Maine introduced adaptive management zones. These large landscape areas were designed to test multiple strategies simultaneously. In each zone, biologists adjusted moose population density, changed habitat structure, monitored ticks more closely, and altered harvest limits. By comparing results across multiple zones, the state could quickly identify what worked and what didn't. This flexible approach replaced the idea of using one statewide strategy for every situation. Instead, Maine began treating moose management as something that must evolve constantly, shifting with every season, every temperature change, and every tick cycle. Even with these actions, the state understood there were no guaranteed outcomes. The scale of the problem made that clear. Saving the moose would require continuous adjustments, cooperation with landowners, engagement with communities, and decisions that might not always be popular. But the alternative, doing nothing, was not an option. Maine chose a methodical path built on data instead of dramatic claims. The state acknowledged the power of a parasite too small to see from afar, but capable of killing animals that once seemed untouchable. For now, Maine's steady, adaptable strategy stands as the moose's strongest line of defense, proving that persistence and evidence-based action matter when a crisis unfolds quietly but relentlessly. Looming danger to moose population. As of 2025, Maine held the largest moose population in the lower 48 states, with an estimated 60,000 to 70,000 animals. Only Alaska had more. This massive herd turned Maine into a major destination for wildlife watchers and hunters, drawing thousands every year. But the size of the population did not guarantee the animals' safety. Even with numbers remaining high, biologists saw warning signs that could shape the future of the species. In recent years, winter ticks have become the biggest threat. Warmer autumns and shorter winters allowed ticks to multiply fast. These parasites targeted young moose in particular. In 2022, researchers recorded an alarming 86% calf mortality rate in a monitored group. The scale of the loss shocked experts and forced the state to test new management strategies. When biologists tried reducing population density in specific zones, calf deaths dropped to as low as 8% by spring 2024. The improvement was real, but the scientists made it clear that the progress was fragile. Tick numbers began rising again, and 2025 looked uncertain. Maine's moose were still numerous, but their long-term survival depended on keeping tick outbreaks under control and ensuring enough calves survived each year. The future of the herd rested on this balance. This situation was even more striking when viewed against the species' history. Maine's forests had once supported only a small number of moose. By the early 20th century, overhunting and habitat loss pushed the population close to collapse. Only a few hundred animals remained in the far northern parts of the state. Their presence was scattered and their recovery was far from guaranteed. Over the following decades, hunting regulations tightened, and abandoned farmlands slowly returned to forest. Young regrowth mixed with older woodland created an ideal feeding habitat. Moose numbers rose steadily. By the late 20th century, Maine had become home to one of the largest moose populations in the eastern United States. It was one of the most notable wildlife recovery stories in the region. Today, the highest densities are found in northern and western Maine, from the rugged area around Baxter State Park to the deep forests of Aroostook County. Yet the same landscape that helped the population rebound is now the stage for a new struggle. Warmer seasons, expanding tick infestations, and unpredictable survival rates have created a cycle that can shift quickly. Wild Maine moose. Moose are built for survival. They can sprint at 35 miles per hour, endure harsh winters with thick fur, and defend themselves from wolves with speed and clever positioning. A newborn calf weighs around 35 pounds, stands within its first day, and gains strength through rapid nursing. But none of these abilities prepared them for a new threat spreading through Maine's forests: winter ticks. This population matters for more than biology. Moose shape tourism, local businesses, and state identity. Hunters and wildlife watchers travel north hoping to see these animals, making their survival crucial to the region's economy and culture. Maine sits at the southern edge of the moose's natural range. Winters here used to be cold enough to limit tick populations, but milder conditions now allow parasites to survive and multiply. As the climate warms, ticks find a longer season to infest moose, putting the herd at risk. When biologists reviewed field reports, a clear pattern emerged. Moose deaths were no longer isolated or seasonal. They formed clusters across northern Maine. Traditional monitoring systems, including research cycles, hunting permits, and basic habitat checks, were not enough to track the crisis in real time. The scale of the problem became impossible to ignore. To close the information gap, Maine launched one of the greatest moose tracking efforts in its history. Crews fitted calves and adult cows with GPS collars that sent location updates every few hours. If a collar stopped moving, teams immediately investigated. This approach allowed biologists to record exact death times, examine remains quickly, and identify causes with unprecedented accuracy. For the first time, the state had continuous data rather than fragmented observations. With the data in hand, biologists faced the challenge of controlling environmental conditions fueling the crisis. One solution was increasing moose hunting permits, not to boost hunting, but to reduce the number of hosts available for winter ticks. Fewer moose meant fewer parasites surviving into the next season, giving the herd a chance to stabilize over time. Maine also worked closely with landowners and logging companies. Timber harvests create large young regrowth zones that attract high numbers of moose, allowing ticks to spread more efficiently. By adjusting harvest rotations and diversifying regrowth patterns, the state aimed to break up these concentration zones while supporting the timber industry. The response became a careful balance between ecology and economy, reducing moose density in some areas, reshaping forest structures, and using real-time data to guide every decision. Maine's new approach marked a shift from passive observation to active year-round management, giving the moose population a realistic chance to recover. Maine moose survival. Maine's moose populations face a delicate balance shaped by survival, reproduction, and calf recruitment. Adult cows typically produce one calf per year, occasionally twins under ideal conditions. But survival rates for calves have become unpredictable due to winter ticks and changing environmental conditions. These parasites can overwhelm moose, causing blood loss, hair loss, and behavior changes. In regions of high mortality, entire cohorts vanish, leaving gaps in population structure that ripple across ecosystems, affecting predators, forests, and future moose numbers. Maine's moose occupy a unique ecological edge. Unlike the vast populations of Alaska and Canada, northern New England moose live at the southernmost part of their boreal range. They thrive in abundant habitats, yet face pressures from climate change, parasitic outbreaks, and human activity. This makes Maine's population a bellwether for moose at the limits of their range. Humans play a crucial role in managing these populations. Wildlife agencies rely on field data, public input, and adaptive policies. Observers, hunters, and local communities contribute insights on collisions, agriculture, and tourism, guiding conservation efforts. Moose are remarkable ecosystem engineers. Standing over 6 feet at the shoulder and weighing up to 1,500 pounds, they survive harsh winters with thick fur and insulating fat. Their long legs and broad hooves allow them to navigate snow, wetlands, and rivers with surprising ease. Seasonal changes shape their behavior. In winter, they conserve energy in dense forests or windswept ridges. Spring brings calves and aquatic diets that maintain wetland balance. Bulls fight for mates in the fall rut, while cows choose partners based on health and strength. Every calf lost to ticks, starvation, or predation affects population structure for years. Mortality comes from predators, harsh winters, accidents, and parasites. Yet each moose contributes to its ecosystem. Carcasses feed scavengers, enrich soil, and influence plant growth. Their browsing alters forest composition, supports birds and small mammals, and shapes wetlands. Moose are also indicators of environmental health. As of 2024, Maine's adaptive management approach has shown results. Calf mortality dropped from 86% to as low as 8% in targeted zones, proving that reducing moose density can break the tick cycle. But the victory is fragile. Tick numbers began rising again as temperatures stayed mild. The moose population remains the largest in the lower 48 states, but its future depends on whether management strategies can keep pace with climate change. Every warm autumn extends the tick's window of survival. Every mild winter allows more parasites to thrive. Maine's moose have survived near extinction before, but this time they face an enemy that grows stronger as the planet warms. Their survival now rests on the balance between human intervention and forces far beyond anyone's control.